Ask GPT 2.5 in 2019 to book you a flight. It writes a lovely paragraph about how flights work. It writes 0 flights. Ask Claude 5 today. It calls a booking API, passes your dates, catches the confirmation number, and puts it on your calendar. Same task, same intelligence in some naive sense. Totally different substrate. The thing that changed is not that the model got smarter, it is that the model learned to emit a tool call. So today the whole video is the tools layer. What a tool actually is, from the model's point of view. How you describe one so the model can call it. How the 4-step loop actually runs. Why every provider now supports basically the same shape. And why tool calls still hallucinate. And what to do about it. I am Ani. Let us go. Video 3 took us inside the loop. Thought, action, observation. We spent 35 seconds on that middle line, action, and moved on. Today we zoom into action specifically. What is happening when the model emits action? Search web query equals 2026 AI benchmarks. Where does that action go? How does it come back? That is what happens inside the ACT slot of the React loop, every single time. The puzzle for this video. Before June 2023, if you wanted an LLM to call a function, you had to parse the model's freeform output with a regex and hope. It was brittle and it broke constantly. Then OpenAI shipped function calling. Anthropic shipped tool use 5 months later. By 2025, every major provider had the same shape. That convergence is the whole reason your agent framework works across models today. If nothing else in this video, remember, schemas are the standard. Today's 3 beats. First, what a tool actually is. From the model's point of view, it is a JSON schema, nothing fancier. Second, the 4-step tool schema loop. Schema in prompt, model emits call, framework executes, result back to model. Every provider works this way. Third, why tool calls hallucinate and the MCP preview, which is lecture 2 territory. Beat 1. What is a tool? From the model's point of view, it is a JSON schema. That is the whole answer. You give the model an object with 3 parts. A name, like search web. A description in English, like searches the web and returns the top 10 results. And an input schema, a JSON schema block that says what parameters the tool accepts and what type each one is. That is it. That is your entire contract with the model. 2 things about that description string. First, the model reads it. That description is not for you. It is for the model. If you write runs a thing, the model will call it wrong. If you write turns the current weather at a given city and country pair, temperature in Celsius, the model will use it well. Second, the description is where you disambiguate similar tools. If you have both search web and search docs, the description is what tells the model which one to reach for. Treat it like a doc string for a very literal-minded coworker. One more thing. That JSON schema in input schema is not an Anthropic invention or an OpenAI invention. It is the JSON schema spec, a standard from 2010 that predates the LLM era by more than a decade. The whole industry converged on it because it was already there. That is why your GPT-5e tools work in Claude 5 in Gemini 3 with tiny wrapper differences. Same shape underneath. That convergence is what makes portable agent code possible today. Beat 2. The 4-step tool schema loop. Step 1. You inject the tool schemas into the prompt. Every one of them. Names, descriptions, input schemas. Step 2. The model reads the user's request, decides which tool to use, and emits a JSON tool call. Structured output, valid against the schema. Step 3. Your framework, not the model, parses that JSON call and actually runs the tool. Whether that tool is a Python function, a REST API call, a shell command, the framework's job. Step 4. The result comes back as an observation, appended to the transcript, sent back to the model. Then loop. Concrete run. Prompt goes in. What is the weather in Tokyo right now? Model reads the prompt and the schema for get weather. Model emits, quote, tool, get weather, input, city, Tokyo, country, JP, unquote. Framework catches that, runs get weather. API returns Tokyo, 27 Celsius, humid. Framework wraps that as an observation, appends to the transcript, sends back. Model reads the new transcript, sees the observation, decides no more tools are needed, writes the final English answer. Tokyo is 27 Celsius and humid right now. 6 moves. That is the whole thing. One important honest thing. The modal never actually runs code. It only ever emits text, a JSON blob, that describes what code to run. The framework, your Python program, your LangGraph node, the Anthropic Agent SDK, is what actually calls the function. That split is not a technicality. It is a safety boundary. If the framework decides the model's tool call is too dangerous, the framework can refuse. The model does not have a way to force execution. Keep that split in your head. Model proposes, framework disposes. Beat 3. Why tool calls still hallucinate? The model can emit a tool call to a function that does not exist, say, delete repo, that you never gave it a schema for, or it can emit a valid schema call with impossible arguments, city equals Atlantis, country equals fictional. Or it can call the right tool with the wrong semantics, asks get weather for a stock price. The framework catches the missing function. It catches malformed types. It usually does not catch semantic errors. Semantic errors are on you. So what do you actually do about it? 3 tactics. Number 1, validate every tool result. If the model asked get weather for Atlantis and the API returned a 404, feed that error back as the observation. Do not silently succeed. Number 2, make tool descriptions specific enough that the model does not confuse 2 similar tools. Number 3, for high-cost tools, add a confirmation step. Model emits the call, framework pauses, human approves. All 3 appear in every serious agent framework. All 3 are unglamorous. All 3 prevent most of the failures you have heard about. Preview. If you have written an agent lately, you have probably heard of MCP, the Model Context Protocol. Anthropic released it in November 2024. Every major provider adopted it in 2025. In one sentence, MCP is a way to package tools so they can plug into any agent without writing custom glue for each provider. It is the tools layer's networking standard. We do not deep dive it today. Lecture 2, Video 2, but know it is coming. And know today's schema mental model is exactly what you need to understand it. 3 takeaways before the quiz. 1. A tool, from the model's point of view, is a JSON schema, name, description, input schema. That is it. Every provider converged on JSON schema, a standard from 2010, which is why your tools work across Claude, GPT, and Gemini with tiny wrapper differences. 2. The 4-step loop. Schema in prompt, model emits call, framework executes, result back as observation. The modal never runs code, the framework does. That split is your safety boundary. 3. Tool calls hallucinate in 3 ways. Made-up tools, malformed types, wrong semantics. Frameworks catch the first 2. You catch the third, with validated results, specific descriptions, and human confirmation on high-cost tools. Quiz 1. From the model's point of view, what is a tool? A. A Python function. B. A JSON schema with 3 parts, name, description, and input schema. C. An API endpoint URL. Or D. A shell command. B. From the model's point of view, a tool is only ever a schema. Name so it can reference it. Description in English so it knows when to reach for it. Input schema so it knows what to pass. What the tool actually does, Python function, API, shell, is the framework's business. The model only sees the schema. Quiz 2. In the 4-step tool schema loop, who actually runs the tool? A. The model runs the tool directly. B. The framework runs the tool. The model only emits a JSON description of what to run. C. The user runs it manually. Or D. The observation runs itself. B. Model proposes. Framework disposes. This split is not a technicality, it is the safety boundary. Because the framework decides whether to execute, you can add guardrails, timeouts, human confirmation, and refusal at that layer. If the model executed code directly, none of that would work. Quiz 3. Which failure mode do frameworks typically not catch on their own? A. The model emits a made-up tool name. B. The model calls the right tool with wrong semantics, like asking get weather for a stock price. C. The model emits malformed argument types. Or D. The model returns invalid JSON. B. Syntax errors are cheap to catch. Semantic errors are yours. The framework does not know that AAPL stock price is not a valid input to a weather tool, which is why the 3 tactics from this video: validate results, write specific descriptions, add human confirmation on high-cost tools, exist. Semantic correctness is a design problem, not a parsing problem. Back to the puzzle. Do AI agents actually reason? After 4 videos, we now know that when the agent takes an action in the world, it goes through a rigid schema-defined channel, which means the agent's reach is bounded by the tools you give it. It cannot invent a new capability out of thin air. It can hallucinate one, but the framework will refuse. That is a small piece of comfort. 4 down, 26 to go. Next time, memory. Your agent can now think, act, and use tools, but it forgets everything the moment the session ends. What are the 4 types of agent memory? Why does RAG not just replace the context window? And why is memory still the messiest unsolved problem in the whole stack? That is video 5. Hit subscribe.